Alright, let's take a look at this first one. X cubed plus 64. So what we're going to do is we're going to set up our parentheses really quick. Remember, one small, one big. We're taking the sum, so this one's the same. Opposite, always positive. That's a terrible one. Sure, that's a plus. There we go. Now we're going to take our terms. So we have cube root of x cubed equals x, and the cube root of 64 is 4. So remember, our first term plus our second term, x plus 4. In the middle they multiply, 4x, and our first term squared plus our last term squared. Now we can't leave it like this because it's 4 squared, so we'll just rewrite it. We'll clean it up a little bit. X plus 4 times x squared minus 4x plus 16. And that's your factors for problem number 1. Alright, let's take a look at example 2. 125 x cubed minus 27, change that to y cubed. So we'll set up our parentheses. We have a difference. So we have little and a little bit larger. We have same sign, opposite, always positive. I'm going to make these parentheses just a little bigger and change the color. So minus, plus, plus. Alright, now we're ready to take the cube root of our terms. So we have 125 x cubed. That comes out to 5x. And we have the cube root of 27 y cubed. And you get 3y. So our first term minus our second term, so 5x minus 3y. In the middle we have 5x times 3y. Clean that up. We have 5x, the whole thing squared. And we have 3y, the whole thing squared. So let's clean it up. We'll write it down here. We get 5x minus 3y times 25x squared plus 15xy plus 9y squared. Alright, to the next one. So again, we have a difference, but notice we always look for the GCF first, right? Look for the GCF first. I don't know why that happened. Look for the GCF first, so we notice we can take out a GCF here, and that is 3. So we take out a 3, and we're left with 64 minus x cubed. Set up our parentheses. And we have the difference. So we have minus, plus, plus, same, opposite, always positive. We take the cube root of our terms. Cube root of 64 is 4. The cube root of x cubed equals x. So we have 4 minus x. Bring the 3 down. bring that out front, because remember we factored it out. We have 4 squared x squared, and in the middle we have 4 times x. So let's clean it up. We have 3 times 4 minus x times 16 plus 4x plus x squared. Alright, let's move on to higher power. If you have a polynomial to a higher power, you're going to do master product. So multiply the first by the last, and you get positive 1x to the 8th. So now we need to find numbers that multiply to positive 1 but add to negative 2. So that's 1, 1, and they're both negative, and it's x to the 4th, because when they multiply together, when they multiply together, you have to get x to the 8th. When you add them, you have to get x to the 4th. So now bring down our x to the 8th, front and back, plus 1. And now we factor by grouping. Cut off the sign a little bit, but it'll be alright. So we have, in the blue group, we have a GCF of x to the 4th. So we have x to the 4th minus 1. And in the green group, we have a factor of negative 1. We'll factor out a negative 1, and we're left with x to the 4th minus 1. So my factors are x to the 4th minus 1 and x to the 4th minus 1. So now we have x to the 4th minus 1, x to the 4th minus 1. They are dots, difference of two perfect squares, so we can factor this as x squared plus 1, x squared minus 1, and x squared plus 1, x squared minus 1. Move this down just a little bit. And we still have some factoring to do, because x squared minus 1 is a perfect square. So we'll bring down x squared plus 1. Can't do anything with that, but we have x plus 1, x minus 1. We have an x squared plus 1 again, and then x plus 1, x minus 1. Now clean this all up. We have x squared plus 1, x squared plus 1, so we can do x squared plus 1 squared. We have x plus 1 and x plus 1, so we have x plus 1 squared and x minus 1 squared. So that is your factors of a polynomial to the 8th power. That's x to the 8th minus 2x to the 4th plus 1. So make sure you factor until you get this, so you can't factor anymore. Alright, one more example, and you can be on your merry way. So we have x to the 4th minus 7x squared plus 12. So we're looking for the master product, 12x to the 4th. And that adds to negative 7x, so we know we have a 4 and a 3. They're both going to be negative. And x squared and x squared. Bring down our 12 and our x to the 4th. We will factor by grouping. Oh yeah, that was good. Dang it. So we have a GCF of x squared down here, So we're left with x squared minus 4. And we're going to factor out a negative 1 over here. A negative 3 over here. And we're left with x squared minus 4. So our factors here, x squared minus 3 and x squared minus 4. Can't do anything with x squared minus 3, but we have dots, and we can have x plus 2, x minus 2. And there you go. That's factoring polynomials to a higher power. Enjoy your day. Alright, today we're going to talk about factoring perfect cubes and higher power polynomials. But first we have to remind ourselves what a perfect cube is. So remember, a perfect square is a number times itself. So 4 times 4, 16. 16 is a perfect square. 5 times 5, 25. 25 is a perfect square. So a perfect cube is a number multiplied by itself 3 times. So let's write that down. So it's the product of a number multiplied by itself three times. Alright, let's take a look at some perfect cubes. So we'll start with 1. So 1 times 1 times 1 equals 1. And if we take the cube root of that, this is how you write it. Inside the little check mark, that's called the index. So you put a little 3 there for cube root. 1 equals 1. So we'll go 2 times 2 times 2. That equals 8. So the cube root of 8 equals 2. 3 times 3 times 3 equals 27. So the cube root of 27 equals 3. We'll do 4 times 4 times 4. That equals 64. And the cube root of that, cube root of 64, is 4. Now let's talk about variables. So like x times x times x. Remember, you're multiplying, you add the exponents, so it becomes x cubed. And you get the cube root of x cubed equals x. So then x squared times x squared times x squared equals x to the 6th. So when you take the cube root of x to the 6th, you get x squared. And you can do this for everything. So like x cubed times x cubed times x cubed would be x to the 9th, and the cube root of x to the 9th is x to the 3rd. So what you can do is you can take the power it's raised to, divide it by the index, and that's the power you'll get. So you'll notice that we started with x to the 1st power, x squared, you go x to the 3rd, x to the 4th. Their answers are multiples of 3, so you get x cubed, x to the 6th. If you did x cubed times x cubed times x cubed, you get x to the 9th. X to the 4th times x to the 4th times x to the 4th is x to the 12th. They're all multiples of 3. So if you did 3 divided by 3, you end up with x to the 1st. 6 divided by the index 3, you get x squared. If you had x to the 9th under there, it would be 9 divided by 3, you get x cubed, and so on and so forth. Alright, let's take a look over here. We have, it says to multiply a minus b times a squared plus ab plus b squared. So let's set that up. So we have a squared plus AB plus B squared times A minus B. So we have, it's a minus. Negative B times B squared is B cubed. Negative B times positive AB is negative AB squared. Negative B times A squared is negative A squared B. Now we set up positive A times positive B squared is positive A B squared. Positive A times positive AB is positive A squared B. And positive A times A squared is A cubed. So we bring down the B cubed here. These cancel, and you're left with A cubed minus B cubed. So notice when we factor A cubed minus B cubed, or the difference of perfect cubes, you will get an answer that looks like that. Alright, let's move on to the next one. Alright, so now it says multiply A plus B times A squared minus AB plus B squared. So we'll set that up. A squared minus AB plus B squared times A plus B. You get B cubed, because positive B times positive B squared. Positive B times negative AB is minus AB squared. Positive B times A squared is positive A squared B. A times B squared is positive AB squared. A times negative AB is negative A squared B. And A times A squared is A cubed. So you get A cubed plus B cubed. And anytime you have the sum of perfect squares, you'll get this as its factor. So notice that when you factor, let's move this up just a little bit. When you factor the sum of perfect squares, you have A plus B. So we have A cubed plus B cubed, and you have A plus B. Then you have A squared minus AB plus. So it goes plus minus plus. Now you look at A cubed minus B cubed, you have minus plus plus. That'll always happen when you factor. So you see this thing down here we call SOAP. I'm sure you've all heard of it before. But if you have the difference of perfect cubes, your first factor will have the same sign. Then your next one will be opposite, and the last sign is always positive. So that's what SOAP stands for. So we'll write that in. So SOAP stands for same, opposite, always, positive. So those will be the signs you set up in your factors inside the parentheses. So you have the same. If it's a sum, it'll be a plus. If it's difference, it'll be a minus. Then the opposite of whatever you're taking, the sum or the difference. And then the last sign is always positive. Alright, so now that we know that, let's factor the difference of perfect cubes. So we'll set up our parentheses. One small, one a little bigger. And we just said we're doing the difference, so we have the same sign here, opposite, and the last sign's always positive. So now we'll factor our terms. So the factor cube root of A cubed equals A, and the cube root of B cubed equals B. And now we're going to plug these in down here. So you get A minus B The middle term is always these two multiplied together. So you get a times b, and then the ends are your first term squared and your last term squared. So you a squared plus positive a squared and positive b squared. Now let's look at the sum of perfect cubes. So we'll set up our parentheses. So we have the sum, so it's plus, minus, plus. We already took our a cubed. The cube root of a cubed is a, so we have a plus b. In the middle, they're multiplied, a times b, a squared plus b squared. Alright, let's flip it over and do some examples.